Hi guys, welcome to Learn with W3 Schools. My name is Dr. Shan, and continuing from previous sessions, today we're going to talk a little bit more about data structures in R programming language. Now, if you have been following me, you will know that I have been talking about R programming language and in previous sessions, already links in the description, you can find it out, or in the eye icons. I have already talked about all these wonderful topics of R and covered all major basics of what R is using W3 Schools website as a reference. In this session, we're basically going to delve a little bit deeper into R programming language, and we're going to talk more about our data structures and other things. So if you're here for the first time and still haven't subscribed, please do subscribe. 90% of my people, you guys are not subscribers. Please do subscribe. It helps the channel a lot. Like the video, leave me a comment and tell me what exactly you're learning with the R, what type of things you're doing with it, and what else you want to know about our programming language. Without further ado, let's begin. Well, what exactly are data structures in R programming? Data structures primarily are defined as something that allows us to store and organize data. The sole purpose of data structures are to understand how we organize the data in our computer systems, inside our computer memory, and how we actually store them, right? So organization and storing of data is a key fundamentals whenever we're dealing with computers and programmers and programming in itself. So data structures basically provide us that primary facility. Okay, so they allows us to and they allows through programming allows and enables us to store and organize data in more professional, standard, and easy to access manners, right? So that's what the primary purpose of data structures are. Okay. R provides many built-in data structures. Each is used to handle data in different ways. For example, by default, we have vector data types, we have list data types, we have matrices, and we have arrays along with data frames. Okay, we will explore all of them in details, but for now, let's have a quick overview of what exactly these databases are. So let's talk about vector. What are vector databases or data structures in R programming language? A vector is the most basic data structure in R. It contains a list of items of the same type. So for example, to declare a vector inside our programming language, we use fruits belongs to C, and then this a bracket star bracket close with the data types defined using comma separated values. This becomes what we call a vector of strings. Because we have used string data types, this becomes a vector of string using with this C as a function and then our values within the round brackets. To use this data, we just simply call the fruits function here. So if you execute the code, you would find that it will print all the vector elements inside the C variable or inside this fruits variable. Okay, so this is how we define a simple vector containing multiple data of same type. This can be string, this can be numbers, this can be floats, whatever type of you're using. You basically define this of data of same type. That's the key thing here. Make sure you define the data of same type. Then we have something called lists. A list can hold different types of data in one structure. That's the key difference between list and a vector. A vector needs to have same type of data, whereas when we talk about lists can have data of different types. Okay, that's what the key fundamental point here is. So whenever we need to define a type of data that could contain multiple different types of data within a list, we basically use a list function. Okay, so a list can hold different types of data in one structure. You can combine numbers, strings, vectors, and even other lists within the same list function. The way we declare it, again, we have a variable. We use the arrow function to assign a value. Then we use a function called list instead of C. C was for vector, list is for the list function itself. And then we define the type of data, all values, comma, separated. So do keep that thing in mind. So if I'm declaring a string, it has to be inside inverted quotations. If I'm defining a string inside inverted quotations, but then because this is a number or an integer, it just uses that value itself without inverted quotations. So now it becomes integer number, and you can have a whole list inside this list as well. And you can have a decimal numbers or whatever type of data you're using. So because we now have multiple type of data inside a single collection, this collection now becomes what we call a list or single structure. This structure is now called a list structure. It differentiates from vector. Vector only contains same type of data. And then the way we declare it is we just use the C keyword, C function, and the rest of the syntax technically is the same. Whereas in terms of list, again, the syntax is same. The only difference is we use the list function and the type of data can be varied. Then we have something called matrices. Now, this is typically from mathematics. You, I'm sure, have studied matrices already. And in R programming, because it is primarily used for analyzing and working with the data, matrices is quite important feature within R programming, and it has built into it. A matrices is a 2D data structure where all elements are of the same type. Again, here do keep in mind, it is a 2D data structure. Technically, we call this as a single 1D data structure. Okay, what this basically means that it only contains single data types, right? Single format, one dimension. Whereas matrices are known as 2D data structure. So when we declare data of type matrices, we basically say, hey, these are two dimensional because it now contains what we call rows and columns. Okay, so it's like a table with rows and columns. Because it contains rows as well as columns, it is 2D. Whereas the type of data that we have in terms of lists or vector, they are called usually 1D because they only have, in other words, single row. There's no column structure to it, or just a column thing. There's no rows inside each of these columns, right? So this is just one column, one column, one column. That's it. There's no rows here. Same goes with the list. But in matrices, we have rows as well as columns. So that's why we call them 2D data structure. The way that they are declared inside our programming language is that we again have a variable. Again, this is a common thing, arrow function, but this time we use a matrix keyword, a function name matrix, bracket start, bracket close. Okay, so main bracket start, bracket close. Inside this, we declare a vector. Again, because we are using C, so we are declaring a vector. Keep that thing in mind. So matrices internally again uses vector, and based on that, it has what we call the unique data of same type. So data of same type, unique data of same type. Okay, so now we have 1, 2, 3, 4, 5, 6. We declare values here. Then we define number of rows 3 and number of columns being 2. So what this is now defining is that it's going to break this data into 2 rows and 3 rows and 2 columns. How it's going to look inside the output. So if you run the code, you would find that it actually prints the rows in a proper matrices format. The way it works is that because we have declared that I have a vector 1, 2, 3, 4, 5, 6, technically this is just a simple vector, but because I've defined it inside the matrices, now it's going to break this into rows and column. How many rows and column? We also have specified this n rows and column. So because there are n3 rows, it's going to take 1 row, it's going to take 2 row, it's going to take 3 row. Okay, so it's automatically has 3 rows now. Then because it says it has 2 columns, so what it's going to do is it's going to take 2 columns from this side, 1 and 2. Make sense? Okay, how the data actually got split, that's something technically part that we need to be a little bit careful about. What it's doing is, because it's taking the data in form of rows and columns, it's going to take the first 3 values, okay, and put them in the first column, and then it's going to take the next 3 values and put them in the next column. Why first 3 values only? Because the number of rows are 3. Okay, hence because we have defined, hey, I need 3 rows, so the first 3 row data will go inside the first 3 column. Then the next 3 data will go inside the next 3 column. We again know matrices always are balanced, number of rows and columns, so we have to be careful about that. So for example, if I specify 6, 7, 8, 9. Oh, sorry, I already have 6. So for example, if I declare this as 6, 7, 8, 9. So now I have added few more data to it. How is this going to look now? If I just squeeze this down like this. So I leave the other values as it is. So we have 3 rows and 2 columns. If I run the code, see, it gives us a warning message that there is not submultiple or multiple of the number of columns. So the number of columns and rows actually now do not meet. So you need to be careful about that. So now it's what we're going to do is we can say, yeah, okay, how about if I change this to 4? So I have 1, 2, 3, 4 on the first row. Then I have 5, 6, 7, 8 on the second row. What about the 9? So again, it's going to throw us this warning message that the data and the length is not basically equally multiple. So what if I delete this now? Now if I run the code, so now because we have defined it 4 rows, it's going to take the first 1, 2, 3, 4 rows data and put them into the first column, and it's going to take the next subsequent data, say 5, 6, 7, 8, and put them in the next column. So that's how basically it is. So it takes the rows first, reads the first 4 data and put them in the rows. Okay, put them in the rows. Then it's going to read the next 4 data and then put them in the next column based on the rows with that. So that's how the rows and columns are formed inside our programming language. And that's how basically we use matrices. Then we have something called arrays. Now, arrays is a common type of data that has been used in other programming languages, but in our programming, they have a little twist the way we use them is like quite a little bit different. So name is same actually, but the way its usability is quite different. So an array is like a matrices, but can have more than 2 dimensions. This is where it becomes more tricky, because usually arrays is again 1D arrays are similar to lists or vectors. But in R programming, they use the arrays, but they make it what we call more than 2 dimensions, means multi-dimensional thing. So the name is same, but the functionality is, I said, quite different. It stores elements the same type in multiple dimensions. It stores elements of the same type in multiple dimensions. So what's happening now is that an array with 1 dimension values ranging from 1 to 24, a comment. So this is an array. We declare a vector 1 to range 24. This becomes the first array. Then we declare a second array. So this becomes like we have one array. Inside one array, we declare another array. So we define another array function. This is an array. So this becomes this array. We take this array's value, and then we define dim is equals to 2432. So this will create a more complex forms of notation. So if you run the code, you would see that first this array is printed 1 to 24. So 1 to 24 values are printed up till this point, all to that point. Okay. So this becomes a single dimensional array. Okay. Keep this in mind. So this is considered as a single dimensional array containing a value range of 1 to 24. Then what we have, then we have another multidimensional array. In this multidimensional array, we took the first dimensional of arrays and then we assign them the second rows and column values. So now we have rows and columns based on this data. Okay, so this is going to split this into what we call a multidimensional array. Then when you print it, we now have a different 2-dimensional array as well. And then you can say that it has even more dimensions with that, and you can add as long as you go with that. So it's something that we're going to explore a little bit more detail in the arrays chapter later on. Okay, but that's what arrays are. It creates a multi-dimensional matrices. Then we have something called data frames. Well, data frame is like a table in a spreadsheet. It's a more common and easier to understand. It can hold different types of data across multiple columns. So it behaves like a table inside your R programming language itself. The way we create it, we create a data frame object, assign it a value called data.frame. Okay, so now notice we are using data.frame. Data becomes an object, .frame becomes its math function, a function of this particular class. Then bracket start, bracket close, and then we say, hey, I have a training is equals to, I define one vector, single dimension, then pulse is equals to define the second data, duration is equals to third data. So now I have defined what we call a simple data frames. It behaves like a table. The way when we print it, you see this is the result. Now what we are getting training, we are getting pulse and duration as a table column, row 1, row 2, row 3 as the number of rows we have based on this data, and then each row value is basically being printed here. So the training data has the value strength, stamina, other. The pulse column has the value 100, 150, 200. The duration column has this value. So see, it's much easier to follow. It's a table form. We have a column name and its values. We have a column and its values. We have a column and its values. And similarly, you can increase the values as well. So for example, if you have duration and for example, date is equals to, so we declare a vector is equals to, and I can say 23rd, and then I can have 22nd, and then I can have 21. And then as soon as I run the code, it's going to execute and add another column to it. So because we have done that, and it's going to give execution halted, oh, comma missing. So because I've added a new column, I have to use a comma here. So accepted symbol in blah, blah, blah things. So now you see we have another new column called date. So no matter what type of data you're working on, you can easily create it in table form, defining a column name as its variable, in other words, equal to, and assign a vector based on its values. So this, whatever you write here becomes the column name, and C vector data becomes its values. That's how we declare data frames inside our programming language. Okay, so quick summary: a vector, single row of values, same type, yes, and simple sequence of data. Less is a multiple types. It does not allow the same type of data grouped by no, yeah. So that means that the data can be of multiple types. Sorry. And then grouped mixed data. Similarly, matrices is a 2D type of data. Array allows us to have a multi-dimensional data. Again, because it's multi-dimensional, always a little bit complex. Data frames, columns of mixed type. So it's based on data table and row form, much easier to understand and follow. And same type no again means that it allows us multiple type of data to be included. So you can have integer, character, short, all inside that. Okay, so this is a quick summary and quick data structures inside our programming language. Follow me for the next session on our programming language. This is Dr. Shan signing off.